Hello, my name is Steven Dom, Director for Automotive Industry Solutions within the Siemens Test and Simulation Solution segment. And today I would like to talk to you about electric vehicle challenges, some trends, and I will also touch on some of the solutions that we put in place in order to work with those challenges and trends. To start with, I would like to talk to you a little bit about the electric vehicle space in the world. This slide may be 2 years old. It's not a lie yet. It says 483 companies are developing electric vehicles around the world. And now this number 483 may not be 100% correct. We see that over the years, and especially in the last couple of years, we've seen a lot of new startups, but at the same time we also saw a lot of consolidation in that market, which means that there is fluctuation. But what is striking to me is that within this space, it's not just China, where a lot of people said like, oh, electric vehicles, it's all developed in China. Well, it's not the case really. It's all over the world. I see in Europe, we see in America, we see a lot of companies working on this technology. And I think that's a proof that this is a global trend and it will persevere. We're sure that it will continue and that electric vehicles will be really the future. If we look a little bit in retrospect, and I will talk about very briefly about sales figures. If you look at sales figures of electric vehicles, you see that in 2015 we were said that there were about, let's say, 500,000 roughly electric vehicles sold, whereas we compare that to 2019, we're already at over 2 million. This is a tremendous growth. But if we look at the growth numbers specifically, we see there very clearly that China has been leading the way, that this is a common knowledge to everybody. But you also see very clearly the effect of the reduced incentives by the government given in China in the last couple of years. You see really a turn of events. You see that the growth in China has really been, it's not stopped, but it's not growing as fast as it used to be. And if you look then at Europe has been increasing its market share. And why is this? This is because we have increased government incentives. If you look at the overall view, of course, then the electric vehicle share is continuously growing. Now, this is until 2019. So now let's look at a little bit of picture for, let's say, the last couple of years and a little bit towards the near future. If you look at these numbers here, you see that when we look at electric vehicle sales from 2019 to 2022, for China, Europe, and the United States, which are the biggest markets, let's be honest, that we project a growth that is quite significant. And actually, if we look at what is the bracket of potential increases, the effect of what COVID has brought, and COVID, it's a global pandemic, we're all experiencing that, yes. The effect has been that governments have actually increased incentives in order to support the automotive industry. And the governments don't want to support combustion engine industry. They see it as a thing of the past. They want to push the companies to actually move into electric vehicles. And the effect will be that, especially for China and Europe, the electric vehicle market share will actually be rather at the top end of the projections. Whereas for the US, where the incentives are not so strong anymore, we know that companies like Tesla and General Motors have reached their 200,000 unit sale limit to actually get incentives. Once past 200,000 vehicles sold, they don't get any incentives anymore from the government. And this effect will be that the contribution from the US will actually slow down, or the growth will slow down. Now, if you look at a much longer term view, which is going to 2030. I don't want to look at 2040, 2050. I think that's a little bit exaggerating. But if you look at the near future, you see that there has been clearly, 2020 a global dip in car sales. That's obviously, that's because of obvious reasons, obviously. You see the COVID pandemic effect there. But what is interesting to see also is the green line, which you see at the bottom here, which is the percentage of car sales that is actually electric vehicle or plug-in hybrids, let's say globally electrified vehicles. That percentage continues to grow unaffected by COVID. It's an interesting thing to note that really the push from governments is toward electric vehicles. Now, let's look a little bit at the challenges for electric vehicles. First of all, we need to think of how electric vehicles are built. First, the basic thing to start with is the global car companies who were building combustion engine vehicles in the first instance have been transforming these combustion engine vehicles to electric vehicles. And a study has shown that when we compare a combustion engine vehicle converted to a electric vehicle, it is essentially suboptimal. It has compromises. So when you build an electric vehicle and you start off from scratch with a completely new blank sheet of paper, you can actually get a much better vehicle. And the case in point is here when you compare the e-Golf to the ID.3, two Volkswagen models. The ID.3, roughly the same size as the Golf, is actually cheaper and has a much larger range than the electric Golf, proving again the point that when you start from scratch to build an electric vehicle, you get a better vehicle. Now, when I look at more the really like electric vehicles that have been from the ground up conceived as electric vehicles, you see that we compare the Opel Ampera with the Tesla Model 3. They're quite different. One has the electric motor in the back, the other one has everything in the front, just like a combustion engine, roughly packaging. Which one is better, which one is not? I have no idea. A priori, both are valid options. And this is actually one of the key things with electric vehicles that we see is that there is no common consensus yet on what is the best architecture to build. And this is a challenge that car companies have. So we've put in place things like Simcenter Studio. Simcenter Studio is a tool where you can work with arbitrary architecture. You can let the computer algorithm choose for you or evaluate for you many different architectures, uses artificial intelligence algorithms to steer that, and you can play around with all kinds of parameters that you see as important in that and figure out what would potentially be the best architecture to go forward. We will talk about that also in other webinars, in other presentations, where we discuss vehicle architecture and tools such as Simcenter Studio, but also Simcenter System Architect and System Analyst, which really support people in making these decisions. Next challenge, I would say, is when we look at the number of electric vehicles that are being launched in the market in the near future. We see that by 2022, some people say there will be 450 new EVs. When I look at another report, I see roughly maybe 500 or 250. If I then look at the longer term and I look at what people are projecting, for example, by 2030, the Volkswagen Group wants to create 70 new electric vehicle models instead of the 50 they were planning before. I see the investments that a company like Hyundai is making in the electric vehicle space. Every single one of these companies that you see here is planning to build a huge amount of vehicles. If you think back in history, and when car companies like BMW or Mercedes, so they were building in the 90s essentially 3 different vehicles, 4 different vehicles. Here we see numbers in the tens of new vehicles to be developed. That is a huge challenge because it's not like the development teams are growing. It's the same development teams that now have to develop a lot more vehicles. And in order to do so, people start from a conceptual architecture that is going to be put on a platform, and you get this skateboard type of concepts. And then a body is going to be put on there. And you see that many of these vehicles, these variants that are going to be developed as variants on top of a common platform. Now, the key challenge then becomes, how do I make my car bodies that are going on top of that, how do I make them good? And good means like strong enough, acoustically good, not having durability issues, all these things, also crash, should not forget that. So if you look at the combustion engine, we could build a combustion engine vehicle. Well, we were going through a body design, and we have experience, and we have benchmarking, and we can set targets for trim bodies, no problem. We evaluate that, and we meet our desired performance quite, I wouldn't say easily, but there is a lot of experience there. Now, when we go to an electric vehicle, with these new types of platforms, with a battery in the floor and a body built on top of that, there really is very little experience. There is also almost no historical data for them. So how do I meet those performances? Yeah? In order to do so, we have accepted this challenge, I would say. Yeah, we're looking at different body concept modeling techniques, saying, okay, I have a new platform, I'm going to explore different designs, and I do that with conceptual body models that are already, let's say, accurate in the sense that they give the right design direction, and we can set targets using that. And then we have another techniques that we developed, which are, for example, linking body design, which is the core body, the body in white model targets, and deriving them from trim bodies. So how to link a trim body performance, where you have all the seats in there, and you have the windows, and you have the trim panels and everything. How do you link that to a basic steel structure of a car body? There has been technologies developed for that. And combining these conceptual body modeling techniques and the linking of the body in white performance to trim body performance gives us elements to actually support the development of a huge number of variants in a shorter time than would have been the case before. Another topic that I want to mention is the integration question. When we look at just in this picture here, which I took from McKinsey, you see different vehicles and how the cooling system for the electronics is working together. You see very different, or should I say, strategies. You see separated cooling systems with distributed management systems on top of that. You see more integration, less integration. But if you look at like consecutive models of the same manufacturer, and I take the case in point which is the most striking here is the Leaf, comparing the 2011 to the 2017 Leaf. There is really steps in consolidating, integrating certain parts, but also distributing parts where it makes sense. And interesting about all these is the idea that when you make things work together better, you actually get to a better vehicle. I read very recently an article about Hyundai and Kia and a test that was done in very cold climates, where their vehicles performed much better than actually standard reports would have made you believe. And the reason they figured out is that Hyundai and Kia make, for example, the air conditioning system, the battery management system, the overall thermal management of the vehicle work together in a much better way than other people. And actually, by integrating, create a much more efficient vehicle. And you see this integration trend also when you look at like the weight of the cables and the number of electric components that are in the vehicle. If you look at a Tesla Model S versus a Model 3, I mean, we go from 14 to 4 electric components. That's a huge step. It means that by simplifying, by integrating, and by making things work together, you get a much better vehicle in the end. Case in point was also a study that was done, and this is actually moving thinking about the electrics integrated in the system, but the same can be said when you look at other systems and the integration. Integrating electrical and mechanical design really reduces your product delivery time, essentially your development time, by a certain percentage, and I don't want to stick to the actual numbers that are here. This is one particular study that shows that, but we know that by integrating, you develop faster and you bring to the market a better vehicle in the end because it is much more balanced. And this brings me to the last challenge that we see, and that's the challenging of attributes. When we look at an electric vehicle, the key or the number one performance that people will look at is the range. And I think we've solved that range issue. Many electric vehicles now will drive 200 kilometers, 300 kilometers, 400 kilometers, some say 1,000 kilometers. So this range question has been solved. We are now 10, 15 years down the road from those first electric vehicles. People are not the early adopters anymore. Early adopters accept some compromise. But when we are looking at electric vehicles nowadays, and we are trying to sell them to the regular people, the everyday user of vehicles, and they will replace their combustion engine vehicle with an electric vehicle just because of it's cheaper to run in the end, they will expect what we call driving performance. And driving performance is not just the speed, but it is also the durability of the vehicle, the ride and handling. It's all the elements that make a car a good car, as well as the comfort, how people feel in the car. It's a very important. The perception of the passenger, the perception of the driver is a key element in accepting an electric vehicle as a replacement for a combustion engine vehicle. So this means that we have to assess the impact of introducing new technologies like the battery pack, which wasn't there, and the electric powertrain, and a different HVAC design, and more complex cooling systems were needed. How they impact things like reliability, NVH, drivability, the thermal comfort in the car. Performance for an electric vehicle, well, the speed and especially the acceleration is not an issue. Usually they actually accelerate much faster than their combustion engine equivalents. But in overall, we need to make sure that the impact of these new systems on what are traditional vehicle attributes is minimal. It should still feel like a good car. And what we do for that is something that, or at least one element in there is, for example, what we call model-based development. The concept behind model-based development is that we go from the very initial design, the architecture of the vehicle, where we have simple models to start with, for many different attributes, or as many as possible different attributes, such as energy management, thermal management, but also driving dynamics, and to a certain extent even NVH. We keep the same model, and we keep this systems approach, this integrated system approach throughout the entire development, and actually keep working with essentially the same model, but in the model replace parts of it with more detailed models. And it can be a 3D simulation model, or it could be a test-based model. And throughout the development, we think of keeping the same system analysis so that we can have comparable analysis, that we can compare the results of what we had in the concept with the results of what we have in the final vehicle. So the entire concept here is keep the same system, and we call it a digital twin. Keep the same digital twin of your system, but refine it, replace parts of it as they become available, and essentially from that initial, let's say, 1D simulation model that we used for the complete system in the concept phase, we go to a full vehicle and test it on a test track using the exact same principles, using the exact same analysis techniques, even with the same analysis software. So it makes consistency throughout the development possible. Just want to, as a very last slide, just give you one example where we have been working with a customer that is Karma in the United States. We were firstly involved a lot with the noise and vibration aspects, but you see that we looked at NVH. We worked together with them on the durability, always looking at the integrated system as much as possible. And the end result is that we also keep in check other attributes, like for example, when we look at motor mouth in July 26 of 2019, they stated the steering wheel is, if anything, superior to Stuttgart's. We're not talking about Stuttgart's specifically, but the fact is that this vehicle actually drives very well. You feel good in the vehicle. And that must be the final goal of any electric vehicle manufacturer. It is to build vehicles that people want to buy at a reasonable cost, but where they feel really happy with what they bought. Thank you very much. That was the end of my presentation.